This is CPM Precalculus Chapter 2, number 37. So suppose that we wish to express the sum of these numbers in sigma notation where the index k begins at 0. Okay, that is saying is we want to start with k here equal to 0. The start is at k is equal to 0. And again, you'll notice that there is an inconsistency. This is not a linear series because you're adding 0.4 to each. So this one we're going to have to change, and this is going to start at 3.6. Okay, so there's a mistake. 3.6 to 4.0 to 4.4 to 4.8 all the way to 23.6. Okay. All right. So let's go ahead and we want to start here, right? We want the start to be at 0. We're going to stop somewhere, and we want some function or expression or argument right here, okay? So first of all, they're asking us in part A, explain why the function to be summed is 0.4k plus 3.2, okay? Actually, that should be 0.4k plus 3.6, okay, because we corrected this, so this has to change too. All right, so why the function to be summed must start with this as the argument? Well, if you look at it, because they require us to start at k is equal to 0, at k equals to 0, right, the first argument, the first term, is going to equal 0.4 times 0 plus 3.6. Again, make sure you change this to a 6. And when you add those, right, 0 times 0.4 is 0, you get 3.6. So if you're starting with the argument at k is equal to 0, you must have this as your expression, okay? And that's because the first term has to equal to 3.6 as it does in our series, okay? So, part B, what is the maximum value of k? Alright, so we know that k starts at 0, right? So this is like, where does it stop? Where does it stop? Or what is stop? What is our stopping point? Okay? So what you have to do here is kind of just to count the terms in between is what you could do. Alright? So that might take a while, right? So what could you do to increase the speed of that? Well, 3.6, so this is term, let me use a different color. This is term number 1, number 2, number 3, number 4, okay? So what number is this one? Right? So that's what we want to figure out. And we could go ahead and write them all out, right? We could go ahead and say, well, 3.6, 4.0, 4.4, 4.8, we're adding 0.4, so the next one's going to be 5.2, the next one's going to be 5.6, right? You can even bring out your calculator and start with 3.6 here, and plus 0.4, right? Add 0.4, add 0.4, add 0.4, add 0.4, right? And keep going and count how many times you're doing that, right? Add 0.4, 6.4, right? So that's one way of doing it until you get to 23.6, and then you just count. This is term 0, this is term number 1, 2, 3, 4, 5, 6, 7, and so on, right? So what's a shortcut to do this? Well, if you look at the pattern, you're adding 0.4, right? So you're going to start with 3.6 plus 0.4k. And when does that equal to 23.6, right? So let's just solve this for k. So subtract 3.6 from both sides, and we get 0.4k is equal to 20.0, right? Divide 0.4 onto both sides, right? So it's 20 divided by 0.4, and we get k is equal to 50, all right? So that means when we get to here, our last number, this is going to be k, right? This is just k, and it's equal to 50 here. All right, so that's how you can kind of do it mathematically, algebraically, and solve, okay? So what is the maximum value of k? Well, stop at k is equal to 50, right? And we just showed our work over there. So let's go ahead and express the sum of part A using sigma notation. So we already know that it starts at k is equal to 0, stops at 50, and what is the argument? We know it's 0.4. They give it to us right here. 0.4k plus 3.6. All right? Okay. So let's go ahead and go to part D. Use the same idea to express 2.5 plus 2.7 plus 2.9 plus 3.1 plus ... plus 22.5 in sigma notation where the index k begins at 0. Okay, so we want to express this. K is equal to 0. So what is the first term going to be? Well, again, it's going to be something times k, just like we had here, right? Plus 3.6, and that was because the first term was 3.6. So we're going to have something times k. So let's say, what are we adding each time? 0.2, right? 0.2 plus 2.5 is 2.7 plus 0.2. So 0.2 times k, right? Plus our initial value, 2.5, right? So that is going to be our argument. We're starting at k is equal to 0, and our last term is 22.5. And what value of k is that equal to when 0.2k plus 2.5 equals 22.5? So let's just solve for it. Subtract 2.5 from both sides, right? We get 20 is equal to 0.2k. Divide both sides by 0.2, right? You can use your calculator. You just know that 20 divided by 0.2 is going to be k equals to 100. All right? And remember, that gives us the max, right? Because we did the last point. And that means we put 100 on the top, showing where we stop. All right? So this is using parts A, B, and C to find and express the same idea for different series. All right. So this ends CPM Precalculus Chapter 2, number 37.